Okay. So let's summarize the analysis for low frequency and high frequency. So for the low frequency, what we'll do is we analyze each cases for capacitor, for each capacitor. So for example, in the common source amplifier circuit, we have 3 capacitor. The first one is input coupling. So we'll analyze only when the input coupling appear. The second case is only when the output coupling appear, and the third case is only when the bypass capacitor appear. So the FLC1 is equal to 1 over 2 pi R signal plus the input impedance times the value of C1. FLC2, due to the output coupling capacitor, this is 1 over 2 pi the load plus the output impedance times the value of the output coupling capacitor. And the last one, the bypass capacitor. The bypass capacitor is 1 over 2 pi the Thevenin resistance at that point times the bypass capacitor. So what is RTH? RTH you receive from at that point, this is RS in parallel with the impedance seen from the source point of the transistor, ZS. The ZS is equal to 1 over GM. Okay, for the MOSFET, the calculation for the impedance at the terminal is very straightforward. So this is just additional information. So this is the equivalent circuit of the hybrid pi model. This is your gate, this is your drain, and this is your source. Okay, the impedance seen from the gate, let's say I put it CG. CG is equal to infinity. Impedance seen from the drain, let's say this is ZD. ZD also equal to infinity. Impedance seen from the source, this is ZS, is equal to 1 over GM. Okay, if you remember this equation, the ZS equal to 1 over GM, so you can have more, you can calculate, do the analysis faster. So RS parallel with 1 over GM. Okay, in terms of the AC analysis at high frequency, so what happened to the equivalent circuit is, in AC equivalent circuit, the parasitic capacitor will appear. Okay, for the high frequency analysis, we will do the analysis separately for the input side and output side. So based on the equivalent circuit, you will find a capacitor, a feedback capacitor that connect the input side and output side. You need to remove this feedback capacitor and replace with the Miller input and Miller output. So the Miller input will belong to the input side, and Miller output will belong to the output side. The calculation of the Miller input and Miller output is given here. So to calculate that one, you need to know the value of voltage gain. Okay, voltage gain. So voltage gain here, this is a common source. This is the minus voltage gain. So minus will be plus. So you can see here the effective capacitance seen at the input port will be much bigger than the actual feedback capacitor, because let's say if the AV is minus 100, so the input impedance will become 101 times bigger than the feedback. Okay, this will affect the cut-off frequency calculation. So once you have simplified, or once you have transformed the circuit by adding the CMI and CMO, you can do the analysis separately at the input side and the output side. So the input side resistance, you need to know the resistance of the input side, RTHI, and the total capacitance at the input side. Okay, in the typical analysis, the total capacitance at the input side is the CWI plus CGS plus CMI. Same goes with the output side. You need to know the effective resistance or Thevenin resistance at the output side, as well as the output capacitance, the total capacitance at the output side. In the typical, we have the CWO plus CMO plus CDS. CDS, usually this is ignored.